question number 7. I'm gonna solve this, and I already also added here your solution side by side so we can pinpoint what is wrong, right? Okay, so let's solve this one first. The first thing, and you just need, I'm sorry, you just need to be really just patient with this thing. Okay, first things first, good practice. Do not try to put your answer all over the place. Okay, so your number 7 is fine. I can see that this is the question. You have your next line, right? So what's only missing is that I do not see the equal sign. So I don't know if this is in reality, this could be a solution to another problem. So just put an equal sign every single line that you do your solution, so whoever reads your problem will know your thought process, and we know which one is step 1 in your head, which one is step 2, and so on and so forth. Okay, so now equal sign. Also, if you have fractions, line up your bars. Okay, so I'm gonna do that. Okay, so now we have a rational expression here, and we have another rational expression. Okay, so the first thing we need to do is to see if there are factors in the numerator and denominator. Well, the numerator doesn't have any factor except x and 1, so we can just keep that x. However, in the 4x plus 8, you can get the greatest common denominator, greatest common factor, which is 4. Now, when you get the greatest common factor, do not just drop it. You have to keep it because we really are just factoring, meaning we are just rewriting this part right here. We're not dividing anything, okay? We're just rewriting it. So that's 4, and then we get the other factor. Now, in order to get the other factor, we need to divide this by that. That's when you get the divide, but you do not get to drop the 4 or the greatest common factor. Okay, so 4x divided by 4, I still have x. 8 divided by 4, I have a positive 2. Okay, so I still have the 4. I did not drop it because I see in some of your solutions that you have dropped 4. All right, next is minus sign, another bar. 1 cannot be factored. And then x squared plus 2. You have a greatest common factor of x. Okay, all right, then we factor it out. X squared divided by this x, you have x. 2x divided by that x, you have 2. Okay. Next, this is the first step basically. Okay. Now, in your solution, you did not do the factoring, so you just combine them. Technically, this is not really wrong. It's not a simplified version. That means you will have to do some cancellations later on, but that's the difference basically. You did not factor this part. Again, not necessarily wrong. Okay, there's just more work involved here. Okay, next is I'm gonna put another equal sign. You can see my equal sign. I try to line them up as best as I could. Okay, now we will try now to get the the least common multiple, which is the common factor. Okay, least common factor. So I'm gonna rewrite this one again. So your least common factor is gonna be all unique denominators, and whichever denominator has a occurs multiple times, you just write them one time. So which ones are those? You have a 4, you have an x plus 2, and you have an x. This x plus 2 is already taken care of by that. Now, when you rewrite your common factor, you rewrite all the monomials first. I'm gonna write 4 and x, and then x plus 2. And I'm gonna do that here as well. Okay. Now, remember that this fraction right here, we wanted to make it look like the denominator is 4x plus 2. So therefore, we will have to multiply this fraction with whatever is not in this denominator, which in this case is, well, you have a 4 and an x plus 2. Therefore, you need to multiply both sides by x. Okay? On the second one, what's missing is 4. So you need to multiply this by 4 over 4. Okay, so now it's a matter of just multiplying the numerators. X times x, you have x squared, and then 1 times 4, you have 4. Okay, now next is we will combine them in one denominator. So since this denominator is not the same thing, we can just write it like this. Okay, and then we can write all the numerators. Okay, all right, so and then in your case, you pretty much did it. This is actually correct up to this point. However, if you notice in this part, you have parentheses, minus parentheses. you cannot cancel this and that because this is not a multiplication in between them, it's a subtraction. You cannot cancel when you're adding or subtracting two things, yet they need to be converted into a fraction form. Okay. All right, so now I can see my, I'm gonna scroll this one up. Okay, so this is my equal sign. I'm gonna do another equal sign here. I'm gonna line them up vertically. Gonna do the bar. I can factor the numerator. That's a difference of two squares. So x plus 2 and x minus 2. All right, and then I'm just gonna copy the denominator, 4x, x plus 2. Okay, now you would know that you can start canceling if first look at your denominator. Is everything in multiplication form? Are they all factors? See that, parentheses times parentheses, that's multiplication. Denominator, 4 times x times parentheses, they're all multiplication. That's when you can cancel. Okay, so this is something that you can cancel, and that's something that you can cancel. So therefore the last answer would be, I'm just going to write this one here because I want to be able to see it. Okay, so what's left is that x plus 2. You don't need to put that in parentheses because that's the only thing that's left, over 4x. And then, of course, we need to do which ones are not going to be, cannot be equal to 0. Okay, so we have these two factors right there. You can say that x cannot be equal to 0. And then from this one, x plus 2 cannot be equal to 0. Therefore, x cannot be equal to -2. So that's what you're writing here. X cannot be equal to, oops, I can't do a wiggly, 0 and -2. Okay, this is your answer. Now, let's go back to the common misconception that students have about cancellation. So let's say you have something like this. X plus 3, x plus 2, x minus 3 plus 5 over x plus 2, x plus 5, x plus 3. Okay. Is this something, we cancel x plus 2 here because you have this x plus 2. Can we cancel this x plus 2 and x plus 2? The answer for that is no, because this is x plus 2, x plus 3. This is a multiplication in between them. But there is a plus 5 here. This is an addition. It's not all multiplication. So if for something like this, do not cancel it out. Okay? It's the same thing as when you have this x plus 5 over x plus 2. You cannot cancel the x and the x because between x and 5, this is addition. Between x plus 2, that's also addition. However, if you have 5x over 2x, 5 and x, that's a multiplication. 2 and x, that's also multiplication. Therefore, you can cancel the x, and the final answer will be 5 halves. Okay? All right. How about something like this? X minus 2, x plus 3 over 5 plus x minus 3, x plus 3. Can we cancel this one out? Again, no. We cannot cancel this and this. We cannot do that because this is a minus 3. So for something like this, what the proper way to do is to simplify, well, keep the numerator x minus 2 because that's already in fraction form, I mean factored form. But this one, you need to simplify 5 plus x minus 3x minus 9, and then simplify some more, x minus 2, x plus 2, and then combining like terms here, 5 minus 9 is -4, x minus 3x is -2x minus 4, right? Because we can combine like terms here now. And then that's when you factor out the denominator, x minus 2, x plus 2. Your greatest common factor here is a -2. I'm going to factor out -2, so therefore I will have x plus 2. See, this one, you can cancel the x plus 2 because that's multiplication between these two, multiplication between these two. Okay, so that's the main difference. Okay, so regarding this problem that you have, I'd like to give you a similar problem that I'd like you to do, and I'd like to see how you do with equal signs and stuff. Okay, so let me erase this, and of course you can just pause the video. Okay, so this is the problem that I'd like you to try. Okay, so try this particular problem, and you can send me the solution. All right.